So the art of multiplying mixed numbers together may at first look a little bit difficult due to the fact that mixed number form doesn't look as simple as other fractions. We give 4 ways of doing this. One of them hopefully will stick. There really is no specific way of doing this except the way that you feel comfortable, and my advice is to know what elements need multiplying, and then you could develop any weird method that you'd like. But to be honest, I think the main important thing here is not to miss any of the elements. Just like when we're expanding double brackets, there are multiple elements to this, and if you forget one, that's where people often go wrong. So converting to top heavy is probably the easiest or the most common. If you just look at my video, you've got a conversion of top heavy to mixed numbers. A real quick recap here is we take the whole and we multiply by the denominator, and then we add the numerator. So here we have 5 as the numerator, and we keep the same denominator as is present in the fraction there. And we do the same for the 3. We got 3 times 3, and then we plus 1, which is 10, and we keep the same. Now multiplying fractions when they're in top heavy form is super easy. There is a video on doing this, but really it's so easy that you could watch this and find out all you need to know. The numerators get multiplied, so I'll write it fully, 5 times 10, and then the denominators get multiplied as well, 2 times 3. Tidy that up. You could do that in your head. I'm just doing it more thoroughly, and you could leave it there at 50 over 60, or you could come back to the original fraction there and cancel before you get to this stage. It's up to you, but I'm just going to continue from here. So now I've got to a point where I cannot simplify anymore, and it's customary to go back to your mixed number. So how we do that, there's a video on my channel about it, but all you do is you think, how many times does 3 go into 25? That's 8 wholes. So we make a note of that, don't want too much in our head at the same time if we can help it. And then we have a remainder of 1, and we keep the same fraction there because we're talking about thirds. Now that's the cheap trick way of doing it, I suppose, but it gets the job done, as some of these things you're doing here just processes, just skills that you have to be able to do. To understand it fully will definitely come in time. And let's have a look at the second one now, the grid. So considering that these numbers here can be written as 7 plus 3 over 7 multiplied by 8 plus 5 over 11, we can see this as a grid expansion. Why would somebody choose a grid method here over other methods? I think it's because people wouldn't want to convert first or do multiple steps. They would know that there's only 4 operations to tackle here, and perhaps it's neater, and it's an extension of some multiplication method that you would have been doing for a long time already, and so it's quite useful that way. So we have a multiplication of 2 numbers made into expansion of 2 brackets, a lot like where we have the algebraic brackets, and we're going to multiply individually. Hopefully we can see that it makes the individual elements a lot easier to see, but we have the issue later. So 8 lots of 3/7, we're multiplying the numerator there, and numerator again for the 7 times 5/11. And finally, it's easy to multiply 2 fractions. We've got the numerators multiplied together and the denominators. Now this method is making it quite easy to do the multiplication and make sure you don't miss anything. That, as you can see, the result here is that we have something pretty difficult to add up. As with the method that you're aware of, the elements in the box here have to be added together in order to finish here. So we've got 56 plus 24 over 7 plus 35 over 11 plus 15 over 77. And I'm looking at this thinking, how can they be added together? Well, common denominators would work here. I think we've got 77 as a common denominator. In order to add these as a common denominator, we have to multiply the top and the bottom of the fraction in order to get 77 on the bottom. So just make a little note with a different color that the first fraction I'm going to be multiplying by 11, and it has to be on top as well. And the second fraction will be multiplied by 7, and it has to be done on top. So we've got 24 times 11, first of all, which is 264. And now we have our 77. And then we've got 35 times 7, which is 245. And we get our 77. And lastly, combination. Now you started to see that this, it seems like a very long method. If we add all of these up and then simplify, we have 524 over, I'll just write this here, it's 56 and 524 over 77. Starting to become a difficult method. This is really useful for fractions sometimes, but it's starting to become a difficult method with all these different denominators. But if we can notice that the fraction in the right here is a top heavy, we'll know that that actually can be cancelled down somewhat. It's probably going to be a certain number of wholes. If we do 524 divided by 77, we actually get that it goes in 6 whole times. Okay, so 6 whole times means we're going to have another 6 added on to our 56 in terms of wholes. And then we can multiply the 77 by 6 and then subtract the 524 from that to give us 62 spare. So that's a very interesting fraction, 62 over 77, because the number 62 has been used twice, so off-putting as it is. And you could just go ahead and at any point double check that the fraction that you've got at the end there is correct by using your calculator. And there's a very nice mixed number function on your calculator that allows you to do that, and I can confirm that that is correct. You'll probably get given it as a top heavy because the calculator doesn't go to mixed numbers very easily, but you'll see that the decimal form is the same as what we have here. And I think you'll agree that the form 62 and 62 over 7, although the fraction part is not brilliant at understanding the size, you can tell that there's 62 wholes in there, which is a lot better than looking at the 4,836 over 77 and wondering really, well, roughly how much is that as a number. We know of a ballpark now, it's roughly 62 and something. Next one would be convert these to a decimal form. When it's nice and easy to see this, I mean, if you prefer working with decimals, then that's great. But especially when they're easy to see the conversion, you could turn them into decimals first. So 3 2/5 is going to be 3.4. And then we've got 5 3/4, which is 5.75. Now, there are all manner of multiplication methods available here. You could use your long multiplication. You could you multiply both of these by 10 or 100 even. Let's just explore that option there. If I multiply this by 100, the same as in fact, I don't need to do that. I could multiply it by 10. Let's keep it that way and multiply this by 100. The effect here is that we have multiplied them so that they're no longer decimals. The question has changed to this. Now, dealing with whole numbers is often a lot easier. You've got your long multiplication methods to deal with this. Now, you've changed the question itself. So the answer to this big old question is not the answer to the original. I mean, for 19,550, how can a number roughly 3 times roughly 6, it should be 18, be equal to 19,550? And it's just for that reason that we realize that the effect that we had by multiplying here has to be undone to bring it back in line with the approximate size that we're interested in. In total, we had multiplied by 1,000, because that's 100 times 10, that's 1,000. Or you could look at it as 10 times 10 times 10. So we need to do the opposite of that, which is divide by 1,000. And that gives us 19.55. And 19.55 is the correct answer. No changes and no further changes. And however you deal with it, that's just one of the methods of dealing with decimals. It depends if you're more comfortable dealing with decimals. I personally much prefer the top method. And lastly, the shorthand arrows. Now, as I said previously, if you're aware of what you need to multiply at any given time, then you could refer back to the method where we had the grid, and you could say, right, in the grid method I had to do 4 times 6 and 4 times 5/7, and 1/3 times 6 and 1/3 times 5/7. This is a method of doing this in your head, although arguably you could do the conversion to top heavy fractions in your head as well, and you could say that was a lot easier. But let's just say we do it this way. We've got 4 times, let's start again without the confusion, 4 times 6, we do it one at a time so we don't get flummoxed, is 24, and then 4 times 5/7, which is 20 over 7. We've got 6 over 3, which is 2. So just think about 6 times 1 over 3, okay? So you can simplify it when it's really easy. You don't want to do too much in your head, but when it's this easy, why not? And then finally, we're adding 5 over 7 times 3, which is 21. Now I can see that my fraction there could do with matching the 21 on the right there, because I'm not going to make the one on the right go down. It's not got any factors that work. It's already simplified, so I'm going to have to take this one up. And the note I'm going to make is that I multiplied it by 3 to get to 21, so I do the same on the top. And I've got this going on. Now let's add the numbers together. So see how many holes we have. And we've got 65 over 21 in the terms of the fractions. Now, because the mixed numbers, if there's an addition between the whole and the fraction, we can just write it without the plus sign. That's where the plus went. This is what we have, a mixed number. And finally, you'll want to convert this to a mixed number properly, where the fraction part is nice and simplified. Now, if you think about 65 over 21, and any factor that goes in, it's actually fully factorized. It'd be nice if there was a 2 or 3, but you know, it's not simplifiable as such. It's set to turn it into an amount of wholes. So if I do 65 divided by 21, I know that 21 goes into 3 times. If you're ever stuck, you could write this 21 times table out separately. So we've got 21, 42, 63, and we could see there, that's all we need to see that 21 goes in another 3 holes. So that's not 26 holes, that's 29 holes. And we have a remainder of 2 out of the 21 that we were aiming to divide it by. Whatever suits you, you have 4 methods there, but that's not a finite list of possibilities. It's not exhaustive. You can develop your own methods as long as you are keeping the integrity of the question. If you change the question, like we saw in this section here, by multiplying it, make sure you undo it. Without the proper balance in maths, you you change the question and it's no longer valid.